this is Mr. T with another calculus tutorial. We're still talking about integration by substitution. And in this example today, we have a problem here, and what I want to talk about is selecting the particular value for u. And in this problem, we really have two different ways that we could select our value for u. And you'll see in the end it's about the same amount of work, but depending on your particular skills, one may be easier than the other. The second method I'm going to show is a little bit less stressful in terms of your fraction usage, so for some of you that might be a better approach. So the first way I'm going to solve it, I'll call it here option 1, will be similar to the way I solved this problem in our previous tutorial. So in our previous tutorial here, we would rewrite this as x times 3x minus 1 to the negative 1/2 power. I would set my u to be the quantity inside of our parentheses. We solve this for x, so we are going to add 1 to the u and then multiply by 1/3 to get the x by itself. So that'll be what we use for substituting here for our x's to get it in terms of u. If we take the derivative of this, we use, remember there's a power of 1, so 1 times 1/3. We subtract 1 from the exponent, and then we take the derivative of what's inside the parentheses, which is du. And if we simplify that, remember anything to the 0 power is just 1, so dx is 1/3 du. So we've figured out our parameters for substitution, so now we're ready to substitute. So let's go about that. So x is being replaced by 1/3 times u plus 1, and dx, now we have the 3x minus 1, that's u, so we have u to the negative 1/2 power. And dx is being replaced by 1/3 du. We can combine these two 1/3s. We get 1/9 and take that outside the integral sign. And inside the integral sign, I'm going to distribute this u to the minus 1/2. So u to the first times u to the minus 1/2, we get u to the 1/2. And here we get times 1, so we get plus u to the minus 1/2. And now we can integrate using our basic power rule. So I get u, we add 1 to the exponent and divide by the new exponent. And likewise here. As you can see in this problem, we're starting to get a lot of fractions, so you need to be good with your fractions. Let's resolve this complex fraction. So this becomes 2/3 u to the 3/2, and this becomes 2u to the 1/2. Now we want to, in this part here, we want to do some GCF factoring. So we can factor out as our constant 2/3. And we factor out our u with the smallest exponent, so that's going to be u to the 1/2. And now we need to figure out our leftovers, so I'm dividing 2/3 u to the 3/2 by this. This 1/9 is out separate. So 2/3 divided by 2/3 is 1, and when we divide here, we subtract the exponent, so we're left with u. And here we have 2 divided by 2/3, which is 3, and our u to the 1/2 cancel out. Let's scroll this up a little bit here. Oops, too far. Okay, now we're ready to, I need to show a little bit more of this here. We're ready to substitute. Well, we can combine this, so 2/3 times 1/9 is 2/27. U to the 1/2, u is 3x minus 1, and then I'm going to write that back in radical notation. And then here u is 3x minus 1, and then we have plus 3. And we're almost done. We can combine like terms here, and our final answer is shown here, 3x plus 2. That's a little involved, and for some of you, this area in here where we have the fractional exponents in our complex fractions and doing GCF factoring may be a little challenging for some of you. So we can make this part at the top a little bit more complicated and reduce those fractions. So let's look at this problem. We're going to work the same problem in a second option. And maybe I should change colors here, so let's work this in blue. This time we are going to let u be our entire denominator, including the radical symbol. Now we need to solve this for x. So to solve a radical equation, we have to square both sides. Now I need to add 1 to get this over here, and then divide by the 3. So I get, whoops, that should be x 1/3 times u squared plus 1. We still need to find our, so this was a little bit more complicated, an extra step here. Now we need to take the derivative of both sides. So we get 1/3 times u squared plus 1 to the 0 power, so that's 1. Now we have to take use the chain rule here and take the derivative of what's inside. So that's going to be 2u du. As I said, this is 1. So when we combine this, our dx value is 2/3 u du. So this part here was a little bit more complicated, but it's going to simplify the steps down here at the bottom. So let's substitute. So we had on the top we had x, so we're substituting for x, so we have 1/3 times u squared plus 1, and the bottom was the square root thing, so that's the u, and now we need to replace dx, and dx is this entire expression here. This u cancels out with this u, and we have 2/3 times 1/3, so I'm going to bring that out front. And then we just have a very simple thing here now to integrate u squared plus 1. And no fractions, so we have 2/9 times u cubed over 3 plus u. So this part here is definitely more simple than what we had over here. We can GCF factor out again. In this case, our constant that we're going to factor out is 1/3, and our lowest power of u is 1. So if I take u cubed over 3 and divide it by u over 3, I get u squared. And here I get 3 when I divide that for my leftovers. And we can combine here 2/27 u, and then we have u squared plus 3. And now we can finish up by doing our reverse substitution. So u is radical square root of 3x minus 1. And u squared we found is here. U squared is 3x minus 1. And finally we can do combining like terms in that parentheses, and you can see that our two answers are identical. So luckily I didn't make any mistakes apparently, because the two answers are the same. And you can get to decide which of these two methods you think is easier. The trade-off on this one, we picked a more complicated u, so figuring out our x and our dx for doing the substitution was a little bit more work. But the benefit down here was we had no fractional exponents to deal with and limited fractions in our terms. Over here we had a simpler selection for u, but then we had a more complicated integral process and a more complicated GCF factoring. So you can choose. Possibly this blue way will be better for some of you. We've stressed here our GCF factoring skills, so some of you may need to go back and review some of the tutorials from earlier in the year on GCF factoring. I hope this helps you, and good luck.